All right, picture this. You're a digital detective, and a very suspicious file just landed on your desk. Is it harmless, or is it a ticking time bomb just waiting to go off and steal data, lock up files, or who knows what else? Our job is to figure out exactly what this thing does, and we have to do it without letting it blow up in our faces. So, welcome to the world of malware analysis. So that's the big question, right? When you're dealing with code that could be seriously destructive, you can't just double-click on it and hope for the best. I mean, that'd be like trying to disarm a bomb with a hammer. No, you need a controlled, totally safe way to peek inside, see what makes it tick, and understand its payload before it ever gets a chance to detonate. And the answer is you build a blast-proof room. In our digital world, we call that a dedicated, isolated lab environment. This is, without a doubt, the single most important rule of this entire game. What happens in the lab stays in the lab. This whole setup guarantees that whatever this nasty file tries to do, it's trapped inside these digital walls, keeping our actual computer and our network completely safe. So here's how we're going to crack this case. First, we'll cover the non-negotiable ground rules for doing this safely. Then we'll actually build our digital crime lab. After that, we'll start dusting for fingerprints with something called static analysis. Next up is the interrogation. That's dynamic analysis, where we see what this thing really does. And finally, we'll turn all our clues into real-world defenses. Okay, first things first. Before we even think about touching any suspicious files, we need to have a briefing. Look, in malware analysis, safety isn't a suggestion, it's not a guideline, it is the absolute foundation of everything we're about to do. If you get this part wrong, the whole investigation is over before it even starts. Seriously. All right, so here are the rules we absolutely live by. Number 1, you always work in an isolated environment, totally disconnected from any network you care about. 2, and I can't stress this enough, never, ever use your main computer for this. And 3, this one. This is our superpower. We use virtual machine snapshots. A snapshot basically lets you save a perfect, clean copy of your lab. Then you can run the malware, let it do its worst, and then bam, with one click, you're right back to that clean state. It's like a time machine for your computer. This whole safe environment we're talking about, we call that a sandbox. And you can really think of it like one of those interrogation rooms you see in the movies, you know? With the one-way mirror, we can stick our suspect, the malware, inside, watch everything it does, see who it talks to, but it can't see us, and it definitely can't touch anything in the real world. It's the absolute cornerstone of doing this safely. Okay, safety briefing is done. Now for the fun part, gearing up. Every good detective needs a forensics kit, a crime lab, right? Well, ours is all digital. Let's get it built. So what you're looking at here is a pretty standard but super effective lab setup. It all runs on your main computer, that's the host OS. Then, inside that, you run at least 2 virtual machines. The first is a Windows VM. Think of this as our bait, our victim machine, where we'll let the malware run wild. The second is a special Linux machine, like Remnix, that pretends to be the internet. We funnel all the network traffic from the Windows machine through it, so if the malware tries to phone home, we can see exactly what it's saying. Pretty clever, right? And inside that lab, we need our tools of the trade. Our investigation basically has 2 phases. On the left, you've got your static analysis tools, like a disassembler. This lets us examine the code without ever running it. It's like reading the architectural blueprints of a building before you go inside. Then on the right, you've got dynamic analysis tools, like a process monitor. This is what lets us watch the malware's behavior in real time as it's happening. These 2 approaches are the pillars of our whole investigation. Let's kick things off with that first pillar, static analysis. You got to think of this as our initial crime scene investigation. We're not running anything. We're not disturbing the evidence. We are just looking, dusting for fingerprints, checking for notes left behind, just trying to find any clues that might hint at the suspect's intentions. Now, the most crucial thing to remember here, and I mean this, is that during static analysis, the malware is never executed. Not a chance. It stays completely dormant. We're essentially putting the file under a microscope and looking at its digital DNA. We're picking it apart, looking at its structure, searching for any readable text hidden inside, and checking the list of special powers it wants to use. All of this helps us form our first guess, our hypothesis, about what this thing is really designed to do. So one of the very first and easiest things we can do is just extract any readable text hidden inside the file. And boom, check that out. We've found an email address and a couple of file paths. These are our first real leads. So now we're asking questions. Is this thing going to try to email someone? Is it going to look for files in these specific folders? These all go into our case notes. And this here is our next big clue. See, every program has to tell Windows what abilities it needs to do its job. It imports these functions. Well, if you look right there, you see it's asking for a function called Internet Connect A. That sets off alarm bells for us. It doesn't prove anything yet, but it's like finding a suspect who's already packed a suitcase and bought a plane ticket. You can be pretty sure they're planning on going somewhere. Okay, we've swept the crime scene, we've gathered some initial clues, and we've got a theory brewing. Now, it's time for the main event, the interrogation. This is where we move into dynamic analysis, where we carefully let the malware run inside our secure lab and watch what it actually does. Yeah, dynamic analysis is where all the action happens. We're finally going to let our suspect make a move, but remember, it's all happening inside our controlled sandbox. And we are watching everything. Every file it touches, every setting it tries to change, every single attempt it makes to connect to the outside world. This is where we find out if our theories from static analysis were right. You know, a classic trick malware loves to pull is to bury itself in the Windows registry. That's how it makes sure it can survive a reboot. So how do we catch it in the act? It's actually a really slick, simple process. First, we use a tool to take a before picture of the registry. Then we let the malware do its thing. After that, we take an after picture and just compare the two. The tool will highlight every single change for us. And there it is. Gotcha. That right there, that's our smoking gun. The report shows it clear as day. Our malware added a new entry to one of the run keys in the registry. That means every single time this computer starts up, our malware is going to start up right along with it. This is what we call a persistence mechanism, and it confirms our suspicions. What started as a theory is now cold, hard fact. So, let's recap. We've gathered the evidence, we've confirmed the behavior. Case closed, right? Well, not quite. The investigation might be over, but our job isn't done. Now we get to the most critical step. We take everything we learned and turn it into a weapon to protect everyone else. It's time to issue a digital APB, an all-points bulletin. The final product of any good analysis is a list of what we call indicators of compromise, or IOCs for short. You can just think of these as the malware's fingerprints. They're the unique, verifiable clues it leaves behind at the crime scene. Things like its file hash, the getaway car's license plate, the phone number it calls. These are the breadcrumbs that security tools use to hunt this thing down. So, let's pull together our final report. What did we find? We've got the file's unique hash, that's its digital DNA. We have the exact registry key it creates to stay persistent. We know the sketchy domain name it calls out to, and we know the exact name and location of the file it drops on the system. See? When you put it all together, you have a perfect wanted poster for this piece of malware. So how do we get this wanted poster into the hands of all the other digital cops out there? Well, one of the most powerful ways is with something called a Yara rule. Now, I know it looks like code, but don't let that fool you. It's really just a simple set of instructions. All this one is saying is, hey, look through all your files, and if you ever see one that contains the text malwaredomain.com, sound the alarm. This isn't just a case file. This is an active defense that tools all over the world can use to automatically hunt for this exact threat. And just like that, our case is closed. Think about it. We started with a completely unknown suspicious file, and we ended with a detailed threat profile that can now be used to protect networks all over the globe. We've walked through the entire detective workflow, from safe setup to static clues and dynamic interrogation. So I guess there's only one question left to ask. Are you ready to build your own lab and start cracking some cases?